Chapter 3. Circle.
Look here. This is a circle. Now this point is called as the center of the circle, and all the points of the circle in the plane are equidistant from this point, and the constant distance is the radius of the circle.
Circles passing through a point. Here we can see point A lies in a plane. All the three circles with centers P, Q and R pass through point A. We can draw many more such circles which pass through point A. That means infinite circles pass through one point. Now circles passing through 2 points. Here we can see 2 points, point A and point B. Draw segment AB. Draw perpendicular bisector L of the segment AB. Take point P on the line L as center and PA as radius. Now draw a circle. The circle passes through point B also. It is according to the property of perpendicular bisector of a segment. Now take another point Q on line L. Draw a circle with center Q and radius QA. It will pass through B. Take one more point, point R on the line L, and draw a circle with center R and radius RA. The circle will pass through B. That means infinite circles pass through two distinct points. Now circles passing through 3 points. Take any 3 non-collinear points A, B, C. Draw a circle passing through these points. This is actually the circumcircle of the triangle. So remember, there is a unique circle passing through 3 non-collinear points. Now take 3 collinear points D, E, F. Try to draw a circle passing through these points. Oh, not possible. So remember, no circle can pass through 3 collinear points.
Now consider a line and a circle in a plane, and tell me in how many points does the line intersect the circle? There are 3 possibilities. Here, line XY intersects circle at points A and B. That means it intersects at 2 different points. In this situation, line XY intersects the circle at only 1 point. And here, the line does not intersect the circle at all, so there is no point of intersection. Now the situation where the line intersects the circle in 2 points, then the line is known as the secant of the circle. So line XY is the secant of the circle. Now, in the second situation, where the line touches the circle at only 1 point, then here line XY is the tangent of the circle and point P is the point of contact of the circle. Here, sec OP is the radius of the circle and OP is perpendicular to the tangent. So remember, the tangent at any point of a circle is perpendicular to the radius through the point of contact. So conversely, we can say when the line perpendicular to a radius of a circle at its outer end is drawn, it is the tangent to the circle. Now remember, there is one and only one line that is tangent to a circle at a given point of the circle. But instead of a point on the circle, if you draw a point in the exterior of the circle, then two tangents pass through an external point of the circle. And the lengths of the two tangent segments to a circle drawn from an external point are equal. So here, length PA is equal to length PB. Now the question. In the given figure, point A is the center of the circle. AN is equal to 10 cm and line NM is tangent at M. So determine the radius of the circle if MN is equal to 5 cm. So first draw seg AM. AM is the radius of the circle and therefore it is perpendicular to the tangent, that is line MN. And therefore triangle AMN is a right angle triangle. Using Pythagoras theorem, AM square is equal to AN square minus MN square. Therefore, AM square is equal to 10 square minus 5 square, that is equal to 100 minus 25, that is equal to 75. Therefore, AM is equal to root 75, that is equal to root 25 into 3, that is equal to 5 root 3. And therefore, the radius of the circle is 5 root 3 centimeters. Next question. In the given figure, there are 4 tangents to a circle at the points A, B, C, D. These 4 tangents form a parallelogram PQRS. If PB is equal to 5, BQ is equal to 3, then find PS. Here, length PB is equal to length PA is equal to 5, as these are the tangent segments drawn from the external point P. Equation 1. Then length QB is equal to length QC is equal to 3 tangent segments drawn from the external point Q. Similarly, length SA is equal to length SD is equal to Y, and length RC is equal to length RD is equal to X. Now PQRS is a parallelogram given, therefore PS is equal to QR, therefore 5 plus Y is equal to 3 plus X, therefore 5 minus 3 is equal to X minus Y, therefore X minus Y is equal to 2, equation 5. Similarly, PQ is equal to SR, therefore X plus Y is equal to 8, equation 6. By adding these two equations we get 2x is equal to 10, therefore x is equal to 5. Putting this value in equation 6 we get y is equal to 3. Therefore, PS is equal to 5 plus y, that is equal to 5 plus 3 is equal to 8. Now we'll see about the touching circles. Two circles in a plane are said to be touching circles or tangent circles if they have one and only one point in common. So here, circle with center Q and circle with center P touch each other, but these are internally touching circles. And here, the circle with center P and the circle with center Q touch each other at point A, and these are externally touching circles. Remember, if two circles are touching circles, then the common point lies on the line joining their centers. Also remember, if two circles are touching internally, both the circles are on the same side of the common tangent, and if two circles are touching externally, then they are on the opposite sides of the common tangent.
Remember, if the circles touch each other externally, the distance between their centers is equal to the sum of their radii. Also, the distance between the centers of the circles touching internally is equal to the difference of their radii.
Now the question: three congruent circles with centers A, B, C and with radius 5 cm each touch each other in points D, E, F. So now, what is the perimeter of triangle ABC? Here, the circles are touching each other and therefore ADB are collinear, then BEC are collinear and CFA are collinear. Therefore, AB is equal to AD plus DB, that is equal to 5 plus 5, as the radius of each circle is 5 cm. Therefore, AB is equal to 10 cm. Similarly, BC is equal to BE plus EC is equal to 10 cm and AC is equal to AF plus FC, that is 10 cm. Therefore, the perimeter of triangle ABC is equal to AB plus BC plus AC, that is equal to 10 plus 10 plus 10, that is 30 cm. Now, the second question is, what is the length of side DE of triangle DEF? Here, triangle ABC is equilateral triangle and therefore angle A is equal to angle B is equal to angle C is equal to 60 degrees. Now, in triangle DBE, angle B is 60 degrees, therefore angle D plus angle E is equal to 180 minus 60, that is equal to 120 degrees. Here DB is equal to BE, radii of the same circle, and therefore angle D is equal to angle E. Isosceles triangle theorem, that is equal to 120 upon 2, that is equal to 60 degrees each. And therefore triangle DBE is equilateral triangle and therefore DB is equal to BE is equal to DE is equal to 5 cm. Therefore, length DE is equal to 5 cm.
Central angle. When the vertex of an angle is the center of a circle, it is called a central angle. Here, O is the center of the circle and angle AOB is the central angle. Here, arc APB is the minor arc and arc AQB is the major arc. Measure of a minor arc is equal to the measure of its corresponding central angle. Here, measure of central angle AOB is theta and therefore measure of minor arc APB is also theta. Measure of major arc is equal to 360 degrees minus measure of corresponding minor arc, and therefore here measure of major arc AQB is equal to 360 degrees minus theta.
Now about the arc of a circle. This is the circle with center O and line AB is the secant of the circle. Therefore, seg AB is the chord of the circle. Therefore, arc AQB is minor arc and arc APB is the major arc. Therefore, measure of arc APB plus measure of arc AQB is equal to 360 degrees, that is the degree measure of the circle. But if a chord passes through the center, then each arc so formed is called a semicircle, and the measure of a semicircle is 180 degrees. So here arc APB is equal to arc AQB is equal to 180 degrees, as sec AB is the diameter of the circle.
Property of sum of measures of arcs. Here we can see a circle. The points on the circle A, B, C, D, E are concyclic. With these points, many arcs are formed. There is one and only one common point C to arc ABC and arc CDE. So, measure of arc ACE is the sum of measures of arc ABC and arc CDE. Therefore, measure arc ABC plus measure arc CDE is equal to measure arc ACE. But arc ABC and arc BCE have many points in common. All points on arc BC. So, measure arc ABE is not equal to measure arc ABC plus measure arc BCE. Now the theorem. The chords corresponding to congruent arcs of a circle or congruent circles are congruent. Given in a circle with center B, arc APC congruent arc DQE. To prove chord AC congruent chord DE. Proof. In triangle ABC and triangle DBE, side AB congruent side DB, radii of the same circle. Side BC congruent side BE, radii of the same circle. Angle ABC congruent angle DBE, measures of congruent arcs. Therefore, triangle ABC congruent angle DBE, SAS test. Therefore, chord AC congruent chord DE, corresponding side of congruent triangle. Next theorem. Corresponding arcs of congruent chords of a circle or congruent circles are congruent. Given O is the center of a circle. Chord PQ congruent chord RS. To prove arc PMQ congruent arc RNS. Proof. In triangle POQ and triangle SOR, seg OP congruent seg OS, radii of the same circle. Seg OQ congruent seg OR, radii of the same circle. Seg PQ congruent seg SR given. Therefore, triangle POQ congruent triangle SOR by SSS test. Therefore, angle POQ congruent angle SOR, corresponding angle of congruent triangle. Now measure arc PMQ is equal to measure angle POQ, central angle, and measure arc RNS is equal to measure angle ROS, central angle. Therefore, arc PMQ congruent arc RNS. Corresponding arcs of congruent chords. The problem. In the given figure, points G, D, E, F are concyclic points of a circle with center C. Angle ECF is equal to 70 degrees. Measure arc DGF is equal to 200 degrees. Find measure arc DE and measure arc DEF. Solution. Angle ECF is equal to 70 degrees Therefore, major arc EF is equal to 70 degrees, as major of a minor arc is equal to the major of its corresponding central angle. Major arc DGF is equal to 200 degrees. Now major of a complete circle is 360 degrees. Therefore, major arc DE plus major arc DGF plus major arc EF is equal to 360 degrees. Therefore, major arc DE plus 200 degrees plus 70 degrees is equal to 360 degrees. Therefore, major arc DE plus 270 is equal to 360. Therefore, major arc DE is equal to 360 minus 270 is equal to 90 degrees. Therefore, major arc DE is equal to 90 degrees. Now, major arc DEF is equal to major arc DE plus major arc EF. Therefore, major arc DEF is equal to 90 plus 70 is equal to 160 degrees.
Now about the inscribed angle. An angle is called inscribed angle in an arc of a circle if the vertex of the angle is on the arc other than its end points and end points of the arc are on the sides of the angle. So here angle ABC is inscribed in the arc ABC and arc APC is the intercepted arc because each side of the angle contains an end point of the arc and all points of the arc except the end points are in the interior of the angle. So arc APC is intercepted by angle ABC.